Hello everybody. So this is actually going to be the part 2 of this tutorial, which I did not expect to do, but I had completely missed a node, which is called RBD Deform pieces. So what this does is it's actually doing the deformation that we did with the point deform. If we look at this, this part, it actually does that, and it also do another thing, which is the big thing. It allows for breaking while still being like doing the whole point deform thing. So it looks at constraints and see, where are you breaking, and when you break, it's going to stop point deforming at that place and also cap, make like a poly cap and whatever. But before you scream, this is still a good thing to know how to do if you didn't know how to do it, because, the RBD deform pieces, it does a lot of things. And if you don't need all of that, it's better to just do it yourself. But we're gonna see if we can like art direct this a little bit based on what we already have, instead of just doing it all over again. So let's get into it. So let's get started. We're gonna do a geometry box again. Let's call this, I don't know, art directing trees or whatever. That's fine. What we're gonna do is we are going to actually pick what we had here. So this, we're gonna pick that. I'm just gonna copy that. So I'm gonna do an object merge. Just paste that in here. This gives us everything. We can start off by just doing it on one, but then I can show you how we can just easily kind of do it in a loop and kind of art direct each iteration. So each three. But let's just, for now, we do a blast and we take, I don't know, tree ID equals 17, let's say, and invert that. And this is what we have. First, we can split. What do we want to, I just want to check one thing. Let's see. Yeah. We can split out the leaves. So let's just organize this. Leaves and the rest. And then we can do another split, I think, and just split out the constraints. Just, make a copy of that. Constraints. So now we have this and the constraints. So let's have a look here. What do we need to do? What do we need to do? So we want to basically pick the things where we want this to be able to snap off on the trunk. So let's just, we can split. I'm not going to do it on the branches. I'm going to stick with the branch is going to be filled with leaves. So I don't even think we need to like do the point deform on the branches. And when I've done it before, before I made a video here, I am getting some weirdness on the point deform. So that's why let's just stick with the trunk, because I don't think we need to do the point deform on the rest. So branches, spelled correctly. So we can work with this. And now to the to where we want this to break. So let's say we want to have it be able to break here. Let's do a split. A lot of splits here. And then we can just press on this, or I believe it's primitives. Press this, and if we go to this one, select groups or connected geometry, we should be able to say like 3D connectivity, as you can see here now, because these are, you know, like we done previously, we did the whole fracturing this up in pieces. So let's take these guys and press enter. So now we have that. Let's call this like, I don't know, details. And then this would be original. If we look here, this is original. We're going to keep this as is. You can do more. You don't have to just do this. But I'm going to stick with this one. And this is where we want to do some things with. We want to fracture this. And I'm going to use the material fracture node. But I don't just want to do it on all of these pieces, because right now, if we look at with explode, we have 4 pieces, and we can have a look. Let's see. Let's do wood, and I am going to skip the grain. Going to lower the density. Constraint, we can create them ourselves. That's fine. Let's keep it like this. And if we were to now do the whole fracturing here, if you want to have it like this, you could, but I don't like this. It doesn't look good to me. So I want to make this 1 piece instead of 4. So how can we do that? Let's do a blast. So here we can remove the inside. This is what we got from when we did our first fracture. This would be these guys. So just do that, and let's drop in a fuse and a polycap, not a polycapture. Really? Come on, Houdini. And maybe we can increase this a little bit. And I'm going to give this a name. Let's give it a name. I'm going to, let's just call it temp. That's fine. So now we have that. And if we now fracture this, we'll be getting something nicer, I think. And we can now play around with this if we want to. So the spacing maybe, height. That's kind of cool. Let's do that maybe. We can see element size. Keep this basically at normal. And there we go with that. So what we need to do here now is create constraints. So before we create our constraints, I think we can do some renaming here. Right now it's this cluster and then an integer. So let's drop down a primitive wrangle. I'm going to use the name here. I'm just going to take the first one. So, you know, it's the name equal and then sprint f, which we have done previously. And then I think it's $s. That would be a placeholder. So S for string. Let's do underscore something, right? So it's, let's do another S here. And the first one is going to be our name. The other one is going to be something. And if we look here, this is what we get. So let's take what we have on this one, and we can use this. I'm thinking, so the 17 is the 3. And the trunk, we can use, maybe we can just use all of it, but let's just look at the split function. So if you haven't seen it before, we can split by something. So in our case, underscore. So if we do a string old name, let's say, it's going to give us an array. Again, this is not a Vex tutorial, but you know, an array can hold a bunch of different values. So if we do a split, so the first one is going to be the subject that we want to split. So we would need to do a prim function. We're coming in from into the second one here, from here. And then we want to say, what do we want to get? I want to get the name. And in this case, I'm just going to say, give me the first one. And then what do we want to split it with? Well, I want to split it with underscore. So if we now look at this and we say, instead of, you know, that, we do like, give me the first one, it's going to be a trunk. Second one, it's going to be 2. Third one is going to be 17. So maybe we can just do like, I don't know, $S again. Then we have like, this would be the trunk. And this would be, you know, the 3. So now we get like cluster, 0, trunk, 3 number 17. That's probably fine. And now let's create the constraints. RB constraint from rules. And also RB constraint properties, so we can assign, you know, what it is. So hard, I'm gonna call this, I don't know, breakable. That's the name for it. Let's do a null so we can look at our beautiful constraints. Right now, as you can see, we're looking at point to point. I think you get some weird deformation with point deform when we have it this way. So I'm going to go with, let's go with surface points. Let's say like 6th constraint per piece. You know, we can always change this, but I think that's fine. Let's see, we are going to merge in our objects. We have that. And we have our constraints, which would also need to merge together. This is the, well, we also need the branches, but we can put that in later. So we have this, and we have this. Now, here's the thing, right? So we removed some shit here. So these have like constraints that doesn't exist. If we look here, you know, trunk 2, 17. And if we look here, name, we go to trunk 2, 17. This shouldn't exist. Let's take a look. Do a blazed. So is it like name? Or maybe we can just, yeah, we can do this, I think. Where, okay, there, can we look at only selected? Pick like this. Oh, we have that on. Okay, so trunk trunk 217, as you can see here, like this doesn't exist anymore. So we want to get rid of this. Not sure if we have to do that, but we're going to do it anyways, just to clean it up. So let's do a prim wrangle on these guys. And let's also bring in this. And let's see. Also not do that. So we have that, that's this. So all of these needs to go from this. Okay, so let's bring those in. Let's just do it in attribute for now, so we can see it. So this is how you would do an array attribute. Call it something. I'm just going to call it like this. There is a unique vals function. Now I can't remember. Let's just see if I can remember it. So it comes from the second input. We want the name. And I mean, I guess we can just do like prim num or something, comma. Or doesn't it do that? Let's see. Press 1 or F1. Geometry. Oh, we need this is actually prim name. And there we go. Let's see. See what we get. And these guys are the ones that we want to remove. And yeah, so let's do that. I'm gonna make this into a string to remove, like so. Now, these guys are on points, right? The names are on points. So we need to basically get every point and the name and then look to see, like, do you have this? Do you have this name? If you do, I just want you to remove the primitive, which, which is the constraint. So let's see if we can do that. Prim point function, right? PTS, let's call it that. It's going to give us 2 values because a constraint has 2 points. So we do an array again, and then we do prim points. And if we look at this, F1, we can see it wants the geometry like most function does, and the prim num. So it's just 0 because it's where it comes in. And then we just do a prim num. And I want to get the name from that. So string, let's call it name 0. And then we do the PTS. No, we can't do that. We do point, because the whole point of this is to just get the exact point number, because it's not like 0 and 1, 0 and 1, 0 and 1. It's, they all have different, and I can't just guess that. So that's why we are doing this, the PTS. So we have that, and then we can use the point function to get the specific attribute that we want, and saying, I want it from this specific point. So if you do 0, which is the input, and then I want to have the name, and then we can do the PTS 0. And if I also do, I'm just going to copy this, say the second point, and we'll just call this like so. And now what we can do is, if we do this in an if, and there is a function called find. So it's going to look in an array. So it's like a, haystack and a needle kind of thing. So the array we want to look at is to remove, and we want to do the name 0. And if that is something greater or equal 0, I think, and then we can just do an OR here. So that's the 2 pipes. Put this to 1. Oops. If we do curly, we do a CD just for the fun of it. See if it works. And there we go. These are these guys. So we can go ahead and just remove, okay, remove prim, and it's prim num and 1, it got removed. If I do 0, it's going to keep the points, but we don't want the points. So now it's all gone. And if we were to look at this, we can now see we have our new constraints, and then we have their old ones. And we don't have a bunch of constraints that we don't need. I'm not sure if you actually need to do this. I haven't tried to not do this. This might actually work without doing all of this work. You can try it. I'm not going to. Now we do need to also create stitching constraint between, let's see, these guys and these guys. So, because if we don't, and we have a collider here, you know, this is just going to glide off. So, and I also want, you know, some of this like jaggy shit to kind of be together with this. We don't want to we don't have, well, at least I don't want to have a clean cut. So let's also do that. We do an RB constraint from rules again, and we can merge. Let's see, we can't merge this guys. We have to merge these guys somewhere. So this is where we have the new name. So we're gonna have to do that because, you know, the constraints need to match the geometry name. And if we do this, RB properties, let's have a look as well so we can see what we're doing. We look at this and we can do group to group, but instead of using group, we can do name, was it like cluster and then star for anything. Copy that and do not cluster. That gives us our stitches. And I'm thinking I'm just gonna go with like surface points again, and maybe we can just lower this a little bit. I don't know. We just need to make sure they are all like together, like so. And I'm going to call this hard trunk again, or should we just do a? This can just be. We already have hard trunk. We could call it hard trunk, and that would be fine. But let's just call this hard detail or whatever. This is not going to break. Just like the rest of the trunk is not going to break. It's only, you know, this part. And if we now, we're only going to take the constraints, by the way. This, we just had to merge it so we can do this whole, you know, clustering thing. It takes like each constraint will get the name onto each point so that it needs to, you know, from the geometry. So where is our, this is the constraints merge or something. And we do have groups and we don't have it on the new one. So we can just, you know, create groups again. This is always good to have. And I call this constraints. So we'll just do that. And this was the yield. And yeah, let's just merge in the rest as well. So the branches needs to be in. Let's see, is there anything else? I don't think there is. And let's just do a null. Call this out constraints detail. I don't know, 3 detail, maybe. And before we put this into a solver, one thing is, if we take a look at this, we're exploding it. We have some weird looking UVs. So we can just UV the insides here, and it's actually going to transfer over from our deform, like the RBD deform pieces. So if we do a UV, I never learn, but let's do UV texture maybe, and say do this on the inside, and it should be fine. We can have a look and just say that, yeah, it looks good. If I don't, and if we want to make this, you know, try to match the size that we have for the rest, we can just play with the scale. Let's do that like so. Can remove this. And another thing is, I want to be able to target the insides here in the shader. So we can do a primitive wrangle, and I'm going to clean this scene file up a little bit before you get it. I'm not going to call it something, I'm going to figure out a good name for it later. So we can just say, like, I don't know, I inside equal 1, and say do this only on inside. So now we have it here. We have zeros and we have ones. And before also, let's just clean up the attributes. We have a lot of attributes that we don't need. These comes from the constraints because they are like, we have merged it. So let's just clean this up a little bit. And let's see, we can keep that. Let's do like everything except for mass name path 3ID. That's good. So mass name 3ID. Did I say something else? I think I did. Path. Like so. Cool. And maybe we can do the same thing here and see what else do we need to like remove. So we don't need. Oh, that's the original. Okay. So I guess we would actually need to do. We can just do this here. Like so. We kind of clean that up. Instead of having all of this, which most of these are just like constraint stuff. And I suppose let's move this here because we don't need it on the branches either. So there we go. And we can also do some cleanup here and see what do we don't need. Well, we need a name on this, but we do not need name on the primitives because for constraints, the name are on the points and not the actual primitive, the line. And where we can keep 3ID. Let's keep path. I don't know, no path, it doesn't really matter. Mass doesn't matter. And name we already removed. Yeah, that's probably fine. If I fucked up, we just go back. But yeah. No name there. Good. And now we should do the simulation. So for the simulation, let's do, I don't know, a box. And yeah, we can do this in a loop later. That should be fine. You can do that in the end if you want to. You probably already know how to do it now in the loop. Because really the only thing that we need to change here is like this. And we can just use a switch. And then, you know, depending on how many trees you have, in our case it's 4 trees, you can do like a, you know, a different split on each tree, and, you know, kind of quote unquote art directed, and rest is just gonna, it's just gonna work. But let's create our collider. Let's make it bigger. Like so. Something like that. Move it up. Do that maybe. And do so. Just move it like so. Okay, cool. We have our animation. I'm just gonna Control A and just click on this straight. So it's just gonna have a same speed all the way through. And I clicked, I just clicked shift click, and you get to this, whatever this is called, animation editor. And let's see now. What do we want to do? What was the typical thing? So the mass, right? So we attribute promote this shit and say primitive like so to point. We do an assemble. Do not create new names. So now we have this in a packed object. We already know this. If you looked at the other video, we want to also, you know, bring out the mass. We can use it. Let's do a dot network. Gonna bring this into the first and the constraints to the second, and then we have the box on the third. And before we do anything else, let's just also fit this to the ground with a attribute wrangle. So on the points, because we've packed it, and let's just say I at active equal, and this is a shorthand, capital letter P, Y, up and down, right? So if you're greater than 2, that's gonna mean, you know, 1, and otherwise it's gonna be 0. So it's fixed to the ground now. And now we do the usual RBD packed object, rigid body solver, constraint network, a merge, ground, you know, all the typical stuff, and a static object. Also make sure that this is like mutual so it works. Otherwise, you know, this is not gonna, we have to make sure that they're all in order. First count, I don't want to repeat myself too much because I'm assuming that you've watched my previous one if you're not familiar with all of this. And for the constraints, I'm just going to copy, you know, some of these. Let's see, where are you? There you are. I'm just going to copy these guys. So the constraints and the break stuff. Go in here. Copy that in here. Take the breaking things. The anim, we don't have that. We do have, I think there was two new. Whoops. Ah, for fuck's sake. So the first one was breakable, and the other one was just hard, I think. And now it should work. It does not work. What are we doing wrong? Hard detail. Oh, did we call it detail? Detail. There we go. So here we go. Sweet. Let's not show this, but we want to show this. And for the static object, we can just do the backtick and do up input path. And for the first one, we're gonna be going up one step, // and then we say the third input, so that's the number 2, and make sure it's using deforming geometry. Otherwise, it's just gonna stand still. Remove bounce. I'm gonna remove friction as well. And on this, very important, we're gonna do have it like this. So remove the compute mass. The stiffness we can play with. Skip the bounce. I don't know what's friction. Whatever. Let's see. So right now, it's not going to do anything. Like, we're not going to break it. Because, you know, we need to tell it to break. So let's go in here. And make more room. Let's do something like that. I'm going to copy this. And do, if you're hard, breakable. And let's say like angle 2 or whatever. And then press this. Now we can play around with that. I'm going to pin it so we can move outside. Do a DOP import just so we... Oh, okay, fuck it. Let's just go with this. And let's see. Are we snapping? Yeah, look at that snap. Look at that snap. That's kind of cool. I want to see exploded view. Oh, that's why it looked kind of boring, because we had this. I forgot to up this again. There we go. You were probably screaming at me there, but I'm just going to drag this in here and say I just want to see like the RBD pact. And now we can take a look at this beautiful thing. Oh, now it's harder to break. Okay, let's go in here. I'm gonna go up again and say 1 then. Oh, there we go. Look at that snap. And, you know, again, you know, we don't have to just use angle. We can use force. That could be a kind of cool thing. I'm gonna do less of this. Boom. Kind of nice. I like it. So as well, something that you can do is we can create an attribute on our constraints that's going to be more, you know, varied. So if we look at this, let's have a look at with the null. What we could do is basically randomize like a strength attribute, or, you know, whatever you want to call it. So I never learned which one of these are the best. not that. Float noise attribute noise, and we can just call this like bend strength. Just gonna copy this, and we can, if we want to see it, we can press the I and do bend strength. It's kind of hard to see now because of we don't have that many. But if we look at the, where is the, oh, we want to do it on the primitives and bend strength. So it should give us a value like roughly from 0 to 1. We can do that. And should we can do a primitive wrangle here, or maybe you can floor it. Post process. Okay, so minimum, maximum. If I do 2 to 1. No, that was not it. Let's skip this and just do it here. And here we can basically say like, again, like bend strength equal, then do a fit 0, 1, because the values are basically like from 0 to 1, and we can say it's the bend strength, and I want you to be from what do we want? 0.5 to 1. So now we are well, that didn't work. Did I spell this wrong or something? Bend strength, fit 0, 1. Oh, it was correct. Yep. So now we have from 0.5 to 1, basically. And then we can, if we want to go in here and say, if angle is, let's do 1 and do like a times bend strength. So basically it's going to be 1 times bend strength. If we do 0.5 maybe, what do we get? Do we get some variation? Test it again. Do we not get bend strength? Let's see, bend. Oh, we have, no. Bend strength, now it's wrong. What are we doing wrong here? Let's see. I mean, this should be all right. Yeah, it probably is. Okay, we have zeros on the other ones, of course. But maybe this was just a bad idea. But this is how you can like randomize things a little bit. But let's see if we can snap it off. Yeah, that's fine. Let's go with that. And let's do the rest of the. So let's finally, you know, let's do the node that I was talking about in the beginning. We have this guy. Let's make this bigger. So what we need, we do need the constraints as well. Constraint network. Why the hell are you colored? Oh, it's because of this. Oh yeah, like so. Okay. So we have the constraints and we have our animated tree, but we do need the constraints to actually follow the animation. Let's start off by splitting this up. So do a null, call this yield, this constraints. And to make the constraints, follow the animation, we do a transform pieces. Just take our animation here, and now we have this. So the ones that are breaking is the like kind of weird. So what the RBD deform pieces do is actually removing these. So like this. Oh, I actually don't have gravity, so let's just add pop force. Cool. Snaps off like that. Now I did, like I think I said it in the beginning, I did get some weird result with point deform with this on the branches, but I don't think we need to do this on the branches because they are like filled with leaves and shit like that. So like, what's the point of doing that? I think at least, but you can play with it. But so I'm just gonna split this up. So I'm gonna say, oh yeah, so maybe we don't actually have, I want to have the path. We don't have that. Okay, so let's have a look. See. Path. Will we have it now? Let's take a look. Now we have the path. We can do what side do we want? Let's call it, this was the branches. And this is the trunk. Like so. So we want to play with this. So I can remove this, we don't need that. Now, RB, what did I call it? Deform, RBD deform pieces. One very important thing, which is really annoying, is that you need to have this at constraints, otherwise it's going to crash Houdini. So make sure this is on constraints. And the first and the last one is the geometry. We don't have a proxy, so we're just going to feed in, the same geometry. It's going to do that, and then the constraints goes like so from our animated constraints. And if we now take a look, it snaps off. Super cool. And then we can do like a merge. We merge these guys back together again. Now, one thing is that this one gives us, on the first one, it's the unpacked one. And the second one is the packed. So you have like the options here. I'm just gonna keep it like, the unpacked one. So let's just, this is not actually unpacked. So I'm just gonna, unpack this. So the thing is, time shift, do it like this, Control Shift, set it to 1, so we're not doing it all the time. We're gonna do an unpack here, and like so. That was not correct. Let's see, we need a name as well, because it tried to match with the name that comes from here that we have somewhere. on the points. We have the name here, and we need the name here. So it basically says so, you know, match with the name. Now we have that. We can remove this, add this in, and there we go. Now we have our snapped off tree. Let's just sim it. And there we go. And also, before we get started, before we take, like, I'm not gonna simulate the leaves here because you can check my previous tutorial on that one. But that is like, you're just doing the same thing. But I haven't made like a quote unquote trailer for this. So I'm gonna do something, and the scene file is going to be in here so you can see it. But yeah, let's take a look at doing this in a for each loop. And we've done this before. For each name primitive. I'm gonna do that. We're gonna go through the tree ID. Let's drag this down here, and we want to merge these guys. We don't want to do the simulation. I'm going to do this. Let's see. It needs to be here. We don't need the blast anymore. And of course, this is like giving us some issues. So we're going to remove this and this. The thing that we need to change is here, right? So the selection stuff. So, you know, if we do single pass, I don't know which, as you can see, if we look at, let's see, it's weird, right? It's just, this is correct. All the other ones are just messed up because of, you know, the selection here. It's meant for this tree only. So if we do a switch, and I think we can do so. We're gonna make another one. Well, let's just do first one first. I think we need to have another switch. And this would be something like this. There. That, I think that works. Now this would probably be number 2. So let's just do, this one would be the second one. Let's remove this one. Like so. It's a bit iffy. So if we were to take second one, which would be this one, and we again, you know, pick the UV connectivity and say we want to have on this one, like, I don't know, this and this. It should be fine. And if we look at the second one, then it's not fine. Why are you not? Oh, because we actually need to change this as well. So we do a metadata. And with this, we have the iteration. So let's just take that. We do a detail function, and we go back for each begin metadata. We want the iteration and just 0. And I'm just going to copy this onto this one. And now we have that. And basically we would need to do the same thing, you know, as many times as we have. Like so, I suppose. And then, you know, you would do the third one, and let's say 3D connectivity, and this is like, okay, break on this one. Like so. Does it look all right? Does, seems to work. Go to this last one. I mean, it's not that automatic, right? But it's wait, was this the same? Okay, that one is just very similar. So now they should work as intended. Let's see. Oh, this was a bit weird. You know, you might not be able to just pick anything. Can I pick this? Or are you gonna be weird? Let's do an exploded view. I mean, that seems to be good. Let's see. Take this, this and this, this, and there we go. You might need to be careful with what you select. Why are you like that? Oh, that could actually be the fuse, is it? Okay, yeah, so let's just do this and this. So you got to be careful with what you select. Why are you not doing anything now for me? What am I doing wrong? This works, this works. This works. What is going on with the first one? This one doesn't seem to want to work. Or are you working? Ah, I'm fucking stupid. Yeah. So I suppose it did work. Just a bad selection, I guess. I don't want to spend too much time on this, but you kind of get it. And then, you know, you would do what we've done before. You would cache this, cache it out, and yeah, let's see. Do we have, I think we have everything. Well, we don't have leaves, though. Let's just also bring in the leaves. like so. And then we have it all. He would cache this, but ID 17, and that gives me constraints as it looks like. And well, that's weird. 316. Oh yeah, we have single pass on. Let's see. So that's 1. Is it all? No. 17. 18. No, this is weird. Is it because we don't have 3 ID 16? Well, we had zeros here. So what is 0? Not this one. It's probably the constraint. We have zeros here, and we obviously have zeros here as well. So, are we not? Maybe we don't. Do we have it all here? Looks like it. So what is 0? Oh, delete not selected. Primitives. Yeah, so that's that. Let's look at where we have our names. It would be somewhere around here. We have the name, and I think it was this. Let's look. Name. Yeah, I believe that is that. So what we can do is we need all the constraints, right? So let's see. If I would just do 3 ID 19, just want to see. Split the constraints. Seems like we have it all here. Just for simple sake, what do we have here? Okay, we can just do the value. I'm just gonna fucking grab this here and just say detail, second input, value 0. So now we should be getting 3 ID. And let's see, 19, 18, 17, looks all right to me, 16, yep. So that's that, and then you would just do the rest. So let's set this up first so we can go into our into the material editor. So we're going to go with this 3, the 17 that we used before. Where are you constraints? That's the constraints. Do that. This. I think, I hope. And yeah, let's just split out the leaves as well. So leaf, gonna do that. Let's just look at this and see if we, or if I fucked something up. Oh, I did. Let's see. Did I not? Oh, okay. We have that. So let's, I'm just going to copy this, do that, and just give it the tree ID there instead. Now it looks correct. Basically, you just make sure that we have all the attributes that we need, but it looks like we do now. So we can go into Karma and just take a look at the material, because I hope that we have the shit that we need. So it was path, yes, and we needed inside. Yes. No, we don't. No. Yeah, we have. Cool. Let's go to Karma. Behind the scenes, I just did a simulation with the leaves as well, so we can have something more pretty to look at. So let's go into Solaris. Press N, click Lops. And here we can go ahead and maybe I should, before that, actually do a null here. So out leaves, and I guess I'm just gonna take this. Maybe we can just do this. I'm gonna copy this and go to Lops, paste that shit in here. Let's see. Yeah, okay, so we have it all. And what I'm going to do, I'm going to just copy the material here. And let's, what do we don't need? Let's skip this. And I'm going to just do star. I'm just gonna paste this in here. That's a branch, that's the leaves. Leaf. Branch. Let's see what is going on. Why are you not working? Oh, did I spell wrong? Okay. Cool, cool, cool. I'm going to take, I don't know, I'm going to take the light that I have in one of my demo scenes. Paste that in here. We can create a camera. And we need a karma. This is going to create a render up as well. Change this to 5 so we don't get an error. Press D, make sure that viewport size is on so we can have a proper render here. And if we just render this now, wow, why are you so freaking slow now? Oh yeah, it's probably because I don't have any proxies here. But let's see, where are you breaking? Boom. And let's have a look. Cool, cool, cool. Let's go in here. I'm just gonna look at the leaves and see. Gonna lower the bump on this bad boy. Let's go to the trunk here. And what we want to do is we want to have different colors, right? So for the inside, and we made one, an attribute. So if we do a geometry property value, and if we click on the trunk, we should see inside somewhere. Let's see. We have inside. Okay, we have a bunch of unnecessary. This shouldn't have this, but that's just, you know, you have to clean that up with the delete attribute before you cache. I didn't cache this. So what the value or the attribute was is inside. And then we need an if equal. You just drop that in here. And I think we need to have like color I think. First one in there, and let's drop in a constant for now. And this is a color. Let's make it red. And there we go. Why is this bump? Did I do this wrong? Interesting. There we go. Or no, was this wrong? Not sure. Let's see. This would be this. There we go. That's more correct. So yeah, that's how you do it, folks. I'm not going to copy this. Color correct, maybe. Drop that in here. In here, do that. And hue, saturation, just make this more. Lift this up a little bit more. That. Can we get like a, I want to see, okay, green. Oh, you should probably have some sort of texture for this. Obviously, you don't want to be that extreme. Or maybe it's just better to do something like this for now. Something like that. And there we go, folks. Now you know how to do that, to do the whole fracturing with point deform. I can't find my words. And let's just double ace this. Oh, look at that, so pretty. Can add some denoising. Oh, I'm using the XPU. That's why it was so slow. Okay, that explains things. Now we're cooking. Or let's see. No, I don't think this actually matters because I'm picking the XPU. Okay, whatever. Camera effect, sure. You know, I think we should have motion blur. Unless I missed somewhere, which I might have. But that is about it, guys. So yeah, have fun with all your new knowledge. See you in the next video.